Hello friends, welcome to the Fastrack video on antennas. So in this video I'm going to talk about antennas and propagation, which will be very much helpful in order to crack UGC NET exams as well as GATE and engineering service examination. Now, how to study with antennas I am going to discuss in detail. See, in the case of EMTL subject, the first topic you have emphasized is based on static field as well as time varying field. In the static field we have focused with respect to electrostatic and magnetostatic. And next one is in the case of time varying field you have focused with respect to the Helmholtz equation, Maxwell's equation, and then you have also been thorough with respect to waveguides and transmission line. So when it comes to antennas, things become frustrated. So my suggestion is, if you want to be in a race, you have to study miscellaneous topics also. Miscellaneous topics are the one which is going to help you. Now in this video, what and all the things I am going to discuss is, I am going to talk about antennas type. You are having dipole, monopole, loop antenna, helical antenna, Arun antenna and paraboloid antenna. And also I am going to discuss about the basic definition or basic parameters like radiation pattern, power density, power intensity or radiation intensity, directivity, gain, directive gain, radiation resistance, beam width, bandwidth, input impedance, polarization, all those things I am going to discuss. Next thing is we have to talk about Frizz formula. This Frizz formula is going to talk about, or it is going to give a relation between received power as well as transmitted power with directivity into consideration. So we came to know, or we got the relation received power equals to, or it is a function of transmitted power and directivity of transmitting antenna as well as receiving antenna, and also it is a function of range and operating frequency. So how can I write receive power, which is equals to Pt into dt dr all divided by 4 by r divided by lambda d whole square. Next topic, we have to know the basic difference between broadside array as well as end fire array. If you are preparing for GATE exams, this topic is important. Now, if I am talking about radio wave propagation, in the case of radio wave propagation, see, we are having two types of communication. One is wired communication and the second one is wireless communication. In the case of wired communication, path is fixed, but in the case of wireless communication, path is not fixed. So in the case of wireless communication, again, how you are going to transmit the signal means surface to surface or surface to sky back to surface. Nothing but what you are going to do is you are going to take the help of ionosphere. You are going to take the help of ionosphere. Thereby you will be getting a reflection of the signal what you have transmitted. Now if you are studying people development and environment, the major layer is you need to be very much focused with respect to troposphere as well as stratosphere. Since you are into communication field, you have to talk about ionospheric propagation. In this we are going to talk about Snell's law as well as maximum usable frequency, and miscellaneous topic is virtual height, skip distance. So this topic is important. So in the case of virtual height, why you are going to take the concept of virtual height means because the earth curvature will be like circular in nature, so you are going to talk about this virtual height. All those things let me talk about later. Now if I am talking about skip distance, what do you mean by skip distance? D skip, which is equals to 2h into under root of f muf divided by fc the whole square minus 1. Now what do you mean by skip distance? Because ionosphere is not a single layer, it will be having a band of layer or group of layer. So the minimum distance you are going to call it as a skip distance. If at all, if you are preparing for December 2020 exam or Jan 2021 exam, Craving Gyan channel has come up with startup bundle package, small groups, all-in-one and dynamite package. So if you are interested, please call to the number 6301356984. Now if I am talking about antenna types, I'll be representing even with the block diagram or like basic structure I am going to write how it will be. Now if I am talking about dipole antenna, which looks something like this. So this is the dipole antenna. Now if I am talking about monopole antenna, it will be like this. So this is monopole antenna. And if I am talking about loop antenna, you should have a loop, right? So this is loop antenna. Similarly, if I am talking about helical antenna is nothing but helical in structure, nothing but it is something like spring kind of thing, right? So it is helical antenna. Similarly, you will be having an Arun antenna. How you are going to represent an Arun? Similar to that, they have just come up with the antenna. So this is Arun antenna. So this is Arun antenna. So you will be getting like this, right? So this is horn antenna. Horn antenna. And next one is paraboloid. Next one is paraboloid. So paraboloid, which looks something like this, right? So this is paraboloid. So this is paraboloid. This is paraboloid antenna. So these are all the basic types of antenna. Just remember the structure. Actually, like structure wise they will not be asking. Just for understanding purpose, I am just giving out with the structures, right? Next, let us talk about basic parameters. Let us talk about basic parameters. See, in the basic parameters, what and all the things we have to discuss. As I discussed, we need to talk about radiation pattern. What do you mean by radiation pattern? What do you mean by power density? What do you mean by radiation intensity? All those things we shall discuss like while analyzing the antenna type, right? Actually, what do you mean by antenna? Basic things is, what do you mean by antenna? Why you require an antenna is important. See, there are two modes of communication. There are two modes of communication. One is like path is defined. See, in one case path is defined. Path will be defined. In the second case, path is not defined. In the second case, path is not defined. So, what is the example of path defined? Nothing but there will be a physical connection. There will be a physical connection. Physical medium will be there for propagation. So, if I want to give an example, the examples are your twisted pair cable and coaxial cable you are going to use for communication purpose. Also, you are going to make use of OFC cable. So, in this case and all, between transmitter and receiver, there is a particular medium, and in this path only the data has to be propagated. In this path only data has to be propagated. But if I am talking about wireless technology, if I am talking about wireless communication, see, in the case of wireless communication, what you are going to do is you will be having a transmitter. So with this transmitter, what you are going to do is you are going to send the signal to the receiver, and you will not be having a predefined path. You are not having a predefined path. In each and every direction you are going to send the signal, right? Only one signal is going to receive to the receiver, or some 3 or 4 signals. Multiple signals you are going to send. Rest all the signals are wasted. Rest all the signals are wasted. So what you require is the transmitted power should be very large. The transmitted power should be very large. Say suppose if I am talking about Akashvani and all, AM communication, they are going to spend some power in the order of kilowatts they are going to spend. But how much power you will be receiving is like at max you may receive some watts of power, or sometimes even milliwatts of power you will be receiving. So kilowatts of energy you are spending, but milliwatts of power you are receiving, and then you are going to process it. Similarly, if I am talking about satellite communication also, the signal what you are going to receive, it will be in the order of like microwatts, or even sometimes it will be in the order of nanowatts. From that you are going to extract the signal, and this is the beauty of wireless communication, right? One simple thing is like, see, you are having a ground surface. You are having a ground surface. On top of this you are having an ionosphere. This ionosphere will be having lots of ions. This ionosphere is helping for communication purpose. How? Send the signal over here. Some signal will be refracted, and majority of the signals will get reflected. Majority of the signals will get reflected, and there will be multiple reflections. There will be multiple reflections, and there are multiple users. So purpose is served. So purpose is served. What do you mean by ground wave communication? What do you mean by space communication? All those things let us discuss later. But as of now, you just assume that you are going to send one signal which is having some high power, and then you are going to just broadcast to the sky. Then ionosphere is the one which is going to reflect back, and this angle of incidence also matters a lot. Angle of incidence also matters a lot. At one angle of incidence, if you are just sending, the signal will not get reflected back. That means the signal will not get reflect back. Entire signal will be moving outside. That means this angle of incidence you have to avoid. Which angle of incidence you have to avoid, which angle of incidence you have to take, all those things we are going to discuss later. Now similarly, if I am talking about what do you mean by antenna means, say suppose a metal rod kind of thing is there with you. For this, what you are going to do is you are going to give current, or you are going to supply current. So the current supply is getting converted into electric and magnetic field. The current is getting converted into electric field and magnetic field. Simple way I am telling you, just remember like this, right? So what you are going to do is, for communication purpose, you want that electromagnetic wave. For communication purpose, either you are in need of electric wave or magnetic wave or electromagnetic, right? It depends on the medium again. Now in this, say suppose if my antenna is somewhere over here, if the antenna is like this, right, what will be the pattern? Nothing but in which direction the majority of the signal is getting propagated. Nothing but either you are transmitting in all the direction, or only in particular direction you are going to transmit, or only this region you are going to focus. So that is what we mean by directivity. Nothing but which direction you are going to choose. Which direction you are going to choose. Again, a simple example like, or the reference antenna always you are going to take is isotropic antenna. This question I have asked today. So isotropic antenna is a one which will emit its power or the signal in each and every direction uniformly. Uniformly it is going to emit, right? Practically we are not going to make use of isotropic antenna. Practically we are not going to make use of isotropic antenna. Why we are not going to make use of isotropic antenna means directivity is approximately 0. So directivity is less. Directivity is poor, right? Next, if directivity is poor means a range decreases. If directivity is poor means a range decreases. So range getting decreased means purpose not served. So don't make use of isotropic antenna. But again, if I want to compare with respect to efficiency of any antenna you consider, you talk about loop antenna, you talk about helical antenna, whatever the antenna you take, the base antenna or the reference antenna will be your isotropic antenna only. So the isotropic antenna is a reference antenna. So isotropic antenna will be your reference antenna, and then you are going to make use of this isotropic antenna only. Now how you are going to calculate efficiency, all those things let us discuss later. What do you mean by efficiency means, like say suppose if I am making use of helical antenna, what is the power in the case of helical antenna divided by power in the case of isotropic antenna, finished. This gives efficiency. How we are going to compare two antennas is the question. Say suppose if I want to compare with respect to Arun antenna, so I will be getting power in the case of Arun antenna divided by power in the case of isotropic antenna. What is the relation between this one? Is it equal? Is it less than? Greater than? So these things are important. So these things are important. You have to go through these things. Nothing but how you are going to compare efficiency with respect to the antennas you are going to study. And now say suppose in this isotropic antenna, it is emitting in all directions. Uniformly it is going to emit in all directions. All directions if it is emitting means the problem is range decreases. Range is getting decreased. So what you are going to do is, in order to increase the range, directivity we want. So if you want to meet the directivity, what you are going to do is, we are not going for isotropic antenna. Then which antenna you are going to talk, right? But before to that we have to talk about radiation pattern. Before to that we have to talk about what do you mean by radiation pattern. Nothing but in which direction most of the waves or the most of the signal is getting propagated. We have to discuss. Say suppose if I am considering a radiation pattern which is like this. Right? Now this is nulls. So let me represent null in a different color. Now what do you mean by null? All those things is not important for you. But as of now, you just remember whatever I am saying, that's more than enough, right? So similarly on this side also you try to extend, right? So this will be your main lobe. Nothing but maximum data or maximum propagation will be in this direction only. And this one will be your back lobe. Back lobe again, it's of no use for us, because main lobe means in that direction we want to propagate. but in back lobe also it is trying to propagate, and that is not a useful one. That is not a useful one. And again you will be having some losses also. Again you will be having losses. That losses will be over here. The small pattern you will be getting over here. Similarly here also you will be getting that small pattern, right? And this is called as side lobes. This is called as side lobes. Say suppose if I am talking about a practical voltage source. Practical voltage source, you will be having that internal impedance of small r, right? That small r is something like this side lobes. Side lobes, like maximum you will be trying to suppress it, but you can't suppress. So this one thing you have to remember. So this is a first null and this is another null. So what do you mean by null? All these things is not important, but as of now you just remember the power pattern. So this figure indicates the power pattern of an antenna. So maximum power you are going to send on with respect to y-axis, nothing but this direction, right? Maximum power is in this direction, right? Or maximum signal you are going to send in this direction. So only I have written it as main lobe. Main lobe area should be more when compared to side lobe as well as back lobe. If main lobe area is more, efficiency is more, then directivity is more, as well as range will be more. But say suppose if I am having an antenna which is like this. So main lobe is getting equal to a back lobe, then absolutely it is 0. Then side lobe is also, if it is like this, then the antenna efficiency directly you can tell only 25%, because 3/4 is getting wasted. 3/4 is getting wasted. So how they are going to design the antenna in such a way that in the case of main lobe it should have some maximum radiation pattern. Radiation pattern should be maximum in the case of main lobe. Similarly, if I am talking about what do you mean by half power beam width, all those things they will be asking. Just remember with the help of diagram, I'll be telling what do you mean by half power beam width. See, in the case of resonance also we have just know that at resonance the power will be exactly divided by 2. The power will be exactly divided by 2, right? So here you will be having this main lobe, and similarly you will be having the back lobe. The side lobes also you will be having. Now from one null to another null, if I am taking, that will be your beam width. That will be your beam width. That will be your beam width. And you are going to call it as half power beam width. Half power beam width. Now, if I am talking about this main lobe, you just consider about this main lobe. Actually, it will not be radiating only in y direction. It will be also propagating in z direction also, right? If I am taking this point at x equals to 0, then the radiation pattern will not be in 2D plane, it will be in 3D plane. Nothing but it will be along y axis as well as along z axis also. So along y axis if I am measuring with theta, along y axis if I am measuring the angle as theta with respect to this point, if I am measuring the value of theta, and along z axis if I am measuring with respect to pi, right? With respect to horizontal plane, what do you mean by beam area? What do you mean by beam area or solid angle? So this question they have asked a number of times. What do you mean by beam area or solid angle? So how it is defined? Directivity, which is equals to 4 pi divided by omega a, where omega a is referred as beam area or solid angle, which is equals to 4 pi divided by the theta with respect to HP and phi HP. So only you remember this formula more than enough. Directivity is given by 4 pi divided by omega a, where omega a equals to theta HP and phi HP, where HP refers to bandwidth in theta as well as phi plane. So bandwidth in the case of theta plane and phi plane is that theta HP and phi HP, right? So these things you have to remember. Again I am going to tell what and all the things you have to remember means, like mainly the thing is what do you mean by antenna? What do you mean by antenna? Parameters are important. That parameters are important, you have to remember, and ionospheric propagation is important. Now, main reference antenna is isotropic antenna. We are going to take this reference antenna. And how you are going to calculate efficiency is important. How you are going to calculate efficiency is important. And in the case of isotropic antenna, it is going to emit the radiation in each and every direction, that too uniformly. That too uniformly it is going to emit, right? And directivity is very much less and range is also less. So only we are not going to prefer this isotropic antenna. You go through previous year question papers, how many times they have asked this question, you will be coming to know. And radiation pattern is important for understanding purpose, right? And this directivity is given by 4 pi divided by omega A. Directivity is given by 4 pi divided by omega A. You please remember this formula also. You please remember this formula, right? Next, we have to talk about gain. Always we have to express in decibels only, right? So similarly, how we are going to express voltage in dB? It is 20 log you are going to take. But if I am talking about current, again it is 20 log. But if I am talking about power, you are going to take it as 10 log of. Directivity D, if I am expressing in terms of dB, which is equals to 10 log of D. Again, unit is important, it is to the base 10. So directivity tells like how narrow the signal is propagating, or the wave is getting propagated. So this is what I mean by directivity. Now the formula of directivity is given by D equals to maximum power density. It is given by maximum power density whole divided by isotropic antenna. Nothing but all the things reference I told, right? Reference you have to take it as isotropic antenna only, right? So it is power density of isotropic antenna you are going to take. Power density of isotropic antenna. So always the reference antenna should be an isotropic antenna. Practically, if they are asking like practically are you going to use a isotropic antenna, you should tell no. Or it is also called as average power density. Average power density. Just remember that reference antenna is isotropic antenna. That's it. Now how we are going to calculate bandwidth when resonance frequency is given? Bandwidth equals to FR divided by Q. Anyway, this formula you have studied in the case of network analysis also. Now one more thing they will be asking, what do you mean by effective aperture? What do you mean by effective aperture? Now what do you mean by effective aperture means it is defined as the ratio of effective power to power density. Right? This power density you can write it as P, or you can just represent by any value or any notation, that doesn't matter. All of you know this formula, that is D equals to 4 pi A divided by lambda square. 4 pi A divided by lambda square. What they want to test you is they are going to give the effective aperture value and then they are going to give the frequency. Lambda equals to C by F. Anyway, you know this formula. Substitute over here and try to get the value of directivity. That's it. So this formula is again important. Preparing for UGC NET, this formula is important. For gate, actually like this questions, simple questions they will not be asking. They will be directly talking with respect to broad fire and end fire. Right? For a UGC NET point of view, you just remember what is the basic difference. That's more than enough. Now, if I am talking about a radiation resistance in the case of lambda by 2 dipole. What do you mean by lambda by 2, lambda by 4, lambda by 3, all those things let us discuss later. But as of now, you just remember a radiation resistance. A radiation resistance in the case of lambda by 2 dipole. See, in the previous years also they have asked, match the following. Radiation resistance equals to 73 ohms they have given. For which antenna? You should remember only the antenna name, that is like in which dipole if they are asking, it is lambda by 2 dipole. It is lambda by 2 dipole. So in the case of lambda by 2 dipole, the radiation resistance is 73 ohms. The radiation resistance is 73 ohms. Now, in the morning test, what the question I have asked based on this topic? See, we are having the types of antenna and let us talk about effective aperture and let us know the directivity. Now if I am talking about isotropic antenna, it is 1, least directivity, and effective aperture is given by lambda square divided by 4 pi. No need to remember, only remember the directivity one, right? Next, if I am talking about short dipole, so in the case of short dipole, actually it is 3 lambda square divided by 8 pi. Directivity should be greater than 1. You remember, directivity should be greater than 1, that is approximately 1.5. Now if I am talking about lambda by 2, it is 30 lambda square divided by 73 pi, right? How can you remember? Radiation resistance of lambda by 2 is 73, that's it, right? What I have asked is this question, 1.64. This 1.64 is for which one? Directivity of lambda by 2, directivity of lambda by 2. So these things, this table you remember, that's more than enough. This table you try to remember, that's more than enough. Next important formula is the Frizz formula. You just flip to your previous year question papers, they have asked with respect to this Frizz formula. What they have asked is, they have not asked problem, they asked only the formula. What they have asked is, what is the received power? What is the received power? So received power is a function of what and what? So received power is a function of the transmitted power into one of you should tell me what do you mean by this dt and dr, and lambda square divided by 16 pi square r square. So it is the directivity of the transmitting antenna as well as the receiving antenna. See, if the receiving antenna directivity is good, then it can receive the particular range of frequencies. And if the receiving antenna is capable of receiving all sorts of signals, then it is your job done that you have to separate those signals. Say suppose if I am designed my mobile antenna in such a way that FM antenna, it has to receive only 88 megahertz to 108 megahertz. So rest all the frequencies this antenna itself is going to reject. So processing becomes very much easy. But if I am talking about military applications, again particular frequency only they have to make a communication. So in that particular frequency they are going to make use of single hopping, double hopping technique, or multiple hoppings they are going to do in order to for hacking it will be very much difficult. So they are going for multiple hopping. So multiple hopping is the one which is going to help them in order to be aware with all those intruders and all, right? So Frizz formula is important, you have to remember this Frizz formula, right? Radiation resistance you remember. You just go through previous year question papers, you will come to know what and all the questions they have asked, right? Now, what do you mean by broadside and end fire? Only one line you have to remember. See, in the case of broadside array, and one more classification is end fire antenna. Students who are preparing for GATE, they have to remember all sorts of equations also. But preparing for exclusively only for UGC NET, no need to remember all sorts of things. See, in the case of broadside, the radiation pattern will be with respect to normal, right? With respect to normal, you will be having this radiation pattern. Right? So this is your reference axis. Right? Next. So if I am talking about few things they will be giving, this is not important, just you remember it is with respect to the axis, right? So this one first null it is at 60 and 60. This is not important actually. And one more important thing is phase difference equals to 0. Now what do you mean by phase difference being 0? All those things, if you want, I will be sharing the material to you, you just read it once. But others, for exam point of view, just remember you are having two types of antenna kind of thing. One is broadside and the second one is end fire antenna, right? Next, in the case of end fire, it is along the axis, right? And in the case of broadside, it is normal to axis. Normal means you just remember it is perpendicular to the axis. Normal means you just remember it is perpendicular to the axis, right? Next, in this case the phase difference will be equals to that phi. Phase difference equals to phi, and you are going to define that psi equals to all those parameters are there, no, all those things you just remember, right? And one important parameter is array factor. I have shared the short notes to you. Array factor you remember. Array factor equals to E naught sine of n psi divided by 2 whole divided by sine of psi divided by 2. So that formula you have to remember, right? That formula you have to remember. Or array factor which is given by cos of psi divided by 2. So when this formula is applicable, when this formula is going to fail, again it is very much difficult to remember. So you please remember that formula, that is E naught sine of n psi divided by 2 whole divided by sine of psi divided by 2. So that formula you remember, and that is with respect to array factor. Antenna array factor they are going to tell. So you should be in a position to tell what do you mean by like broadside and end fire. So how the things is going to vary. A little bit of classification you should know. Little bit of classification in the sense this phase difference term you should know. Phase difference terms, if you are knowing, it is more than enough. And they will be asking with respect to directivity also, right? If I am talking about directivity in the case of broadside, it will be 2 times of L lambda, where L lambda equals to 2 times of ND divided by lambda, ND divided by lambda, right? But in this case, the directivity is given by under root of 2 times of L lambda. What do you mean by L lambda? It is ND divided by lambda, ND divided by lambda, right? So these things you have to remember. Basic difference, if you are knowing, that is more than enough. All these things are not important. What you have to remember is whether it is normal or whether it is like with respect to axis, you have to remember. Now what sort of question they have asked in the previous year? See, simple question they have asked, match the following. For short dipole, we know that length is very much less than lambda. Even antenna length also matters a lot. It depends on the wavelength what you are going to choose. So L is very much less than lambda. How much it is less? See, it is lambda divided by 50 times less. This one they have asked. They have not asked what is the value. They have asked in the case of short dipole, match the following again. For the short dipole, L is very much less than lambda. L is very much less than lambda. So these kind of questions they have asked, right? Now, if I am talking about the difference between broadside as well as end fire, sorry, if I am talking about next difference, what do you mean by near field and what do you mean by far field? So this one actually, like if you are preparing for gate, no, you would have gone through these things. What is the difference between near field and end field or far field? Now, why you got this near field and far field means with the help of one expression you got. See, in that expression, if you are deleting that distance square, distance cube terms, then it is like near field. But if you are considering the range into consideration, then it is far field, right? So what is that expression you will be getting is from Maxwell's equation you will be getting this expression. H phi equals to current into length into sine of angle whole divided by 4 pi into j omega plus 1 divided by r square. Whether you are going to neglect this one or you are going to consider this one is important. Whether you are going to neglect this one or whether you are going to consider this term is important. See, in the case of far field, you are going to neglect. In the case of far field, you are going to neglect these terms, that is 1 by r square term plus 1 by r cube term and so on terms you are going to neglect, right? Only the first one you are going to consider, 1 divided by r you are going to consider, right? And then you are going to solve. Now what is the basic difference means you are having some formulas, that E naught formulas is there. In the case of far field, E naught equals to 60 pi into I L sin theta whole divided by r lambda, right? Whole divided by r lambda. Similarly, here also you will be getting some big expression you will be getting, no need to remember, right? What is important, you just remember how this formula is getting modified in the case of near field and far field is important. In the case of near field, you are going to consider h phi equals to I into L sin theta whole divided by 4 pi into j omega divided by RC plus 1 divided by r square. Directly you are going to take, no need of any approximation. But in the case of far field, what you are going to take is h phi equals to I into L into j into I into L sin theta whole divided by 2r lambda. Now one thing what you have to remember is, in the case of near field you are going to consider each and every patterns, right? But in the case of far field you are going to neglect that 1 by r square terms and then you are going to solve. Only these things you are going to remember. Next, one more problem, one more question what they have asked is with respect to lambda by 2 dipole antenna, that is radiation resistance, right? Radiation resistance equals to that 73 ohms they have given. Now if I am talking with respect to lambda by 2 dipole, lambda dipole as well as 3 lambda by 2 dipole, as well as 3 lambda by 2 dipole, what is the radiation resistance you have to remember. See, in the case of lambda by 2 dipole, radiation resistance equals to 73 ohms. Radiation resistance equals to 73 ohms. What do you mean by this lambda by 2 means length you are going to take it as lambda by 2. Here length you are going to take it as lambda. Length you are going to take it as 3 lambda by 2. So at that time one formula is there, right? In the case of field patterns, that is cos of beta L divided by 2 into cos theta minus cos of beta L by 2 whole divided by sin theta. That beta L you are going to make use. What do you mean by beta L means, like beta is given by 2 pi by lambda into L means what you substitute. If you are taking it as lambda by 2, you try to substitute over here, you will be getting this pi term. So substitute over there, cos pi equals to minus 1 and then you are going to substitute, right? So this is with respect to lambda by 2 dipole and lambda dipole as well as 3 lambda by 2 dipole. Nothing but what you are going to change, you are going to change the length. You are going to change the length and then you are going to solve. Now one important thing is, like what do you mean by V antenna? Maybe chances is there that this time they may ask with respect to V antenna. See, in the case of V antenna, the radiation pattern will be in the form of V. In the form of V. So the radiation pattern will be in the form of V. So this is V antenna. Now if I am talking about both the directions, it will be like this. So the radiation pattern will be towards left as well as towards right. Nothing but it is like this. Similarly, right? So this is the radiation pattern. So this is the radiation pattern of V antenna, right? You just remember these things. That is more than enough, right? Next is we have to talk about monopole and what do you mean by dipole we have to speak. And today's question was based on this one only. What do you mean by monopole and what do you mean by dipole? One question I have asked. See, we know that radiation resistance equals to 80 pi square into dl divided by d lambda the whole square they are going to take, or you are going to take it as L divided by lambda the whole square or L square divided by lambda. So this is radiation resistance, right? If I am talking about monopole, see, in the case of dipole, what you will be having is, you will be having the radiation pattern in both the direction, right? But in the case of a monopole, either it will be on the upwards or it will be on the downwards. So the radiation pattern is fixed. See, in the case of monopole, can I tell the radiation resistance is exactly equals to half. The radiation resistance is exactly equals to half because only half of the part you are going to consider. So what is the radiation resistance formula? Again, it should be divided by 2 only. That is 40 pi square into L divided by lambda the whole square. You just remember this formula. What is the formula I have given is, I have just given this formula. In today's mock test, I have given this formula. In order to test you how well you are in antennas, I just gave this problem. So this problem was based on radiation resistance. But what in UGC NET has tested till now is with respect to radiation resistance of this one. That is 80 pi square divided into L square divided by lambda square. Only this one they are testing, right? Only this one they are testing. Rest of the things they have not touched. Rest of the things till now they have not touched, right? So you just remember the formulas based on this. It's more than enough. So they are not asking like the problems based on these things. What they want to test you is only if you can able to remember the formulas or not. That's what they are testing, right? Now, so this is all about antennas. Only the overview I have given. Now let us talk about radio wave propagation. How we are going to transmit the data. So let us talk about radio wave propagation. Radio wave propagation. See, if I am talking about radio wave propagation, what and all the things we have to discuss is like we have to talk about atmospheric layers. See, in the case of atmospheric layers, we are having 5 layers, right? Starting from troposphere, stratosphere, mesosphere, ionosphere and exosphere. Now, for propagation purpose, ionospheric propagation is important. And if I'm talking about people development and environment, they will be talking about only these 2 layers, that is troposphere and stratosphere. Now, if I am talking about UV rays will be in which 2 layers? You have to tell it is in troposphere as well as stratosphere. Ozone will be in which layers? You have to tell it is present in both the layers. It is present in both the layers. But the tropospheric ozone is going to harm us, but the stratospheric ozone is going to protect us. Again, I am going to repeat. This ozone will be present in tropospheric as well as stratosphere layers. But tropospheric ozone is there, no, that is going to harm us. Nothing but that is not going to protect from harmful UV rays. But if I am talking about stratospheric ozone, it is going to protect us from harmful UV rays. So this is important. And sometimes they may ask with respect to what is the thickness of that ozone. Just don't tell it will be in terms of kilometers and all. Just don't tell it will be in terms of kilometers or some meters and all. It will be in the order of just millimeter, right? Mm range. So that much thin layer is going to protect us from harmful UV rays, right? So ionospheric propagation, nothing but for communication purpose, we are going to make use of ionosphere. And again in that one you are having some several layers, A, B, C, D, E, F layers are there. When you are going to make use of E layer, when you are going to make use of F layer, at the daytime communication is different, at the nighttime communication is going to be different, right? Nighttime and daytime communication is going to be very much different. So these things you have to remember, right? For extra understanding purpose, you can just think that in the case of F layer, you will be having F1 layer as well as F2 layer. In the daytime and night time, it will not be present. Only at one moment of time it is going to be present. So all those things is not important. Only the thing is like you just remember few basic terms, right? Now, what do you mean by ground wave communication or surface wave communication? They may ask you. See, in the olden days, if I am talking about the height of the antenna was in terms of meters only. The height of the antenna was in terms of meters. Why they used to increase the antenna? That too on top of hills only they used to place this antenna, right? Why means like, say suppose if I want to transmit from this place to this place. So here I have installed one antenna. Here I have installed one more antenna, that is transmitted antenna as well as received antenna. Now what I am going to do is I am going to just send the signal. I am going to try to send the signal. So it is going to hit to the ionosphere and then it will rebound back, right? This is one way. The other way is like it may have a straight path also. So if it is having a straight path, then it is line of sight. Line of sight is important. But some waves, instead of going up, what it is going to do is it is going to fall down and then it is going to reflect back. So this way is also possible. This way is also possible. Multiple paths actually you are having. With which path you are going to consider is left up to the design aspect, right? So always you are going to prefer this line of sight. Always you are going to prefer this line of sight. Where exactly you are using this line of sight concept means you are going to make use in DTH concept. DTH concept you are going to send to the satellite and then you are going to reflect back. It is going to reflect back. So for each and every operator they have given some particular angle. So the design engineer, when you are the engineer, when you will be coming to your house for installation of the setup box, he will be having one device with him. So he is going to tune to that particular angle, and then if he can able to receive that signal, then you will be telling not to touch that plate again and again. So that one instruction he will give and then he will go. So what they are doing is a particular angle they are going to set and then they are going to leave. So DTH is going to operate in line of sight. But if I am talking about our mobile communication and all, there is no line of sight required. There is no line of sight that is required, right? And you please remember this range also. Very low frequency, medium frequency and high frequency. What is the range? One time they have asked. Very high frequency and ultra high frequency. All this range is important. If I am talking about very low frequency, the range is of 30 to 30 kilohertz. The range is of the frequency range is of 30 to 30 kilohertz. If I am talking about low frequency, it is 30 to 300 kilohertz. 30 to 300 kilohertz, right? Audible frequency is 20 to 20 kilohertz. It is a low frequency range. They may ask this sort of question also, right? And if I am talking about medium frequency is again 300 to 3000. 300 to 3000 kilo, or you can write it as 3 mega also, not a problem. Here it is 3 mega to 30 mega. Same pattern is going to repeat, right? Next is what? 30 mega to 300 mega. Next is what? The 300 mega to 3000 mega, or you can write it as 3000 giga also, right? Next will be 3 giga to 30 giga. So this, anyway, if they are asking with respect to arrange in a particular frequency order, you can easily arrange. But if they are asking like medium frequencies interval is what? And in analog communication they have asked with respect to like that audio signal frequency range is what? At that time you will get trapped. So what is the audible frequency range, and our ears are sensitive to which particular range? 2 to 20 kilo is wrong again. See, if I am listening to a music, for me each and every frequency is important. But each and every frequency if I am transmitting, bandwidth requirement is more. So what they are going to do is they are going to suppress the particular range. Nothing but maximum they will be taking some 200 hertz to 3 kilohertz maximum. That much range only they are going to take. So if you are interacting via cell phone, only that much range only they are going to give. Say you are playing some sound in 20 kilohertz, or you consider 10 kilohertz also. With the help of your cell phone, it is not audible, right? That means they are going to restrict it. And then they are going to play, right? And if I am talking about what do you mean by range of like digital communication, what is the range, all those things, you just go through it. Like as of now it is like end moment. What you have studied, only those things you remember. So rest all the things I'll try to give some important things. So try to focus that one, that is more than enough. Now let us talk about ionospheric propagation. In this you have to remember only the technical terms. What do you mean by skip distance? All those things are important. Only the terms you remember. If you can able to remember the formula, it is well and good. Now how this ionosphere they are going to build, means it has built. So it is like you consider this one as a ground surface. You consider this one as a ground surface. Say if you are moving upwards, nothing but what is happening, height is getting increased. So a rate of ionization also will be increased. So if I am moving upwards, then a rate of ionization will try to increase. What is getting decreased means molecular density is going to decrease. Molecular density. Molecular density, you just remember air. So air will be available at the ground surface. Say if you are climbing a hill, at that time you will be having that sensation, like breathing problem will be there. Because of this, air molecules are less in number. That means like molecular density is low. And you just talk about the Siachen also. The Siachen glacier is there, no? But the temperature is also low and it is at a high distance, and moreover each and every person is attacking that area, right? So these things you just remember. Why we are remembering means with respect to molecular density, that's it. As height increases, molecular density decreases, right? So these things you remember. Now what do you mean by skyway propagation means? In the case of skyway propagation, actually what you are going to do is, in the case of skyway propagation, you are going to send the signal to the sky propagation. So you will be having the earth surface, you will be having this earth surface, and you will be having this ionosphere also. So when you just try to send, you will be getting a received signal, and earth will be acting like a perfect, like it is like earth will be also acting like a reflector kind of thing. So you will be getting multiple reflections. You will be getting multiple reflections. Here there is no concept of line of sight. The signal can be like this also. So at that time you will be having multiple reflections. You will be having this multiple reflections. So this is in the case of skyway propagation. And from Snell's law, if you are speaking, from Snell's law if I am speaking, so this formula is also important. See why Snell's law is important means entire your optical fiber works on Snell's law. Only the thing is you are going to take angle of incidence as critical angle and then you are going to solve. Such that angle of refraction is equals to 90 degrees, and then you will be getting the perfect signal or perfect propagation you will be getting. So what does Snell's law tells means, it is like if I am talking about the refractive index of the first medium as N1, and if I am talking about the refractive index of the second medium as N2. So what is the angle of incidence you have applied the signal with respect to normal? That one they are going to call it as theta I. That one they are going to call it as theta I. So it is sine of theta I into some amount of signal will get reflected back. Some amount of signal will get reflected back because there is a change in medium. But majority of the signal, instead of taking the same path, there will be a deviation. There will be a deviation. And this is called as angle of refraction. This is called as angle of refraction. So it is sine of theta r. Sine of theta r. So this is what I mean by Snell's law. This is what I mean by Snell's law. You remember this one also. Try to remember. Right? Next, with this what actually they want to prove means with respect to operating frequency they have to prove. So what is that operating frequency they have taken is f equals to 9 root of n maximum. That equation we got today now. So that equation they want to derive. Right? The maximum frequency or the critical frequency that is given by fc, which is equals to 9 times of under root of n max. So based on this only I have asked in today's mock test. Now where fc is the maximum frequency or maximum operating frequency, actually how you will be getting is you will be getting the sine theta I. You will be getting sine theta I, which is equals to under root of 1 minus of 81 times of n max whole divided by f square. If you want derivation and all, how you will be getting, you just go through any question paper, sorry, any textbook, they will be giving this derivation. It is 9 times of root n max whole divided by cos theta I. Cos theta I. Actually, how you are going to transmit means you are going to transmit like this. Say suppose if this is the earth surface, and this is the ionosphere. You're going to send like this. At an angle of 90 degree, you're going to send. Entire wave will get reflected. Nothing but it is not been getting into some deviations at all. So received power is 0 only. Received power is 0. Now what do you mean by this N max? N max is like it is like density of ions in terms of electrons per meter cube. In terms of electrons per meter cube, that's how they are going to define it. That's how they are going to define. Okay, so this formula is important. So this formula is critical frequency. This formula is critical frequency. Critical frequency is given by 9 times of under root of n max, right? And also they may ask you what do you mean by very low frequency, how the pattern will be there, all those things they may ask you. And very low frequency, high frequency, and ultra high frequency, how the things that is going to vary. So these things they may ask you. And last topic I want to discuss, what do you mean by virtual height and skip distance? What do you
Excuse
mean
me,
by
sir.
yeah?
Sir, if you can please repeat that concept. If the wave is traveling at critical angle, what will happen?
In this case, actually what is the thing that is going to happen means, like if I am talking about critical frequency, if I am talking, right, say suppose if my angle of incidence equals to 90 degree, means exactly vertically I am going to throw my signal. I am going to place an antenna exactly equals to like sun's direction at 12 noon, and I am going to send the signal. So what is the thing that is going to happen means, it is going to hit that ionosphere and it is going to take the same path. It is going to take the same path. Nothing but there will be many receivers over here. There will be many receivers which is placed at some distance. That signal will not be received. That signal will not be received. So always you should not take this path. Nothing but exactly vertical path you should not take. So only what you are going to do is, we are going to just tilt it with an angle. So with an angle, if you are just sending the signal, it will be reflected. It will be reflected back. Right?
Sir, what is that frequency? Sir, what is that frequency which is divided, if critical frequency is divided by the cos theta incident angle, then what is that frequency?
This is a maximum usable frequency, FMUF.
Maximum usable frequency. Oh,
Maximum usable frequency. Maximum usable frequency. So depending on cos theta I, what is the value you will be getting, like maximum regeneration you can do. Nothing but maximum receivers can able to receive that signal. If you are just sending it in this, like at this particular angle, if you are sending. If at all, if you want to know more in detail, this maximum usable frequency will be something like this. Say suppose if you are considering this one as a earth surface. Say suppose you consider this one as an earth surface. Actually you are going to send like this. Nothing but some sort of tilt will be there. So you will be getting 1 over here, and what you will be having is, this ionosphere is not a single layer. This ionosphere itself is split up into many layers, right? So you will be getting some multiple reflections you will be getting, and some signal, no, it will be just jumped. It will be jumped. Which frequency will be jumped? Which frequency will not be getting reflected back means, the frequencies which is greater than the maximum usable frequency, those frequencies will not be a reflected one. Nothing but it is not getting used properly. So always you are going to maintain the frequency which is less than FMUF. Always you are going to make use the input frequency which is less than FMUF. So this is the angle of incidence. So with respect to normal, you are going to calculate the angle of incidence. Only you remember this one. The frequency greater than FMUF, or maximum usable frequency, that is not used. But nothing but that data will be lost. Say suppose you are sending the data which is from 30 to 30 giga. And if the FMUF, nothing but maximum usable frequency, if it is set at 30 mega, greater than 30 mega is lost. That signal is lost. So this is what they want to define in terms of this formula, that is maximum usable frequency. that is 9 into root of n max whole divided by cos theta I, where theta I is nothing but angle of incidence. So this is what they want to convey in this case, right? Similarly, what do you mean by virtual height in the case of antenna propagation or like signal propagation? Say suppose this is earth surface. Because of ionosphere, you will be getting a bent kind of thing. Because straight line you can't pass. So what do you mean by virtual height? Means you try to extend this line. When you try to extend this line, what is the thing you will be getting is, you will be getting this height to be an actual height. So this is your actual height. But what is virtual height? This distance is your virtual height. You thought that signal will be going up to this distance, but couldn't because of ionosphere. Right? In the case of ionosphere, actually your signal will not be like this. Perfect bent you will not be getting. So you will be getting a multiple reflections. Say if I am extending this one, I will be getting a virtual height. What they are asking is like, what is the concept of virtual height? That's it, right? If at all, if they are asking what is the concept of virtual height, they may ask you, right? And one more thing is there. What do you mean by that skip distance? They are going to ask. See, in the case of skip distance, if I want to tell, you will be having a multiple reflections. The least path is considered as a skip distance path. So let me consider this is my earth surface. Now what I am going to do is, I am having a band of ionosphere. You consider I am having band of ionosphere, right? This is ionosphere layers. It is not a single line. It is actually some like kilometer range it will be there, right? Now if I am sending the signal from ground station, one signal may go over here and it may come. So this is one. Next signal, instead of taking the same path, it may take the another path. It will be like this. One more signal, what it is going to do is, it is going to just touch and then it is going to reflect back. So it all depends on at what angle of incidence you are throwing the signal. And one more incidence is there. What you are going to do is, you are going to just throw at this angle. When you throw at this angle, like if it would have been ionosphere, if it would have been extended till here, it would have just reflected back. But ionosphere is not up to there. So only this path will be having. Above this there will be no any reflection. So this signal will not get reflect back. What is the minimum distance you have achieved? Say this is your transmitting antenna. Here you have received, and this is referred as skip distance. So like minimum range is denoted by your skip distance. And angle of incidence, based on angle of incidence, your range is also varying. Say suppose if I am like applying my signal at theta 1 is best or theta 2 is best? Theta 1 is best, because range coverage is more. Why we are going to increase the angle of incidence means, because of you are very much concerned with respect to gravitational pull. So only you are going to increase the angle of incidence, and range is getting limited. For everything there exists a trade-off. If you want one, you have to lose one, right? So these things are important. And the last topic is, we have to just remember that skip distance formula. Skip distance formula is given by D equals to 2 times of H into under root of, they are expressing in terms of maximum usable frequency, F times of MUF divided by critical frequency, that is FC whole square minus 1. So this formula you just remember. Chances is there that they may ask or they may not ask. That doesn't matter. Only the thing is, you just remember that formula. Now what do you mean by that? H means you just take it as height. Say from year to year, if I am taking, I have written that ionospheric height, right? So that ionosphere height is that one. Nothing but for the skip distance, you just consider this height. You just consider this height, right? And you can call this height as capital H. You can call this one as capital H, right? Why I am taking this H means because I am talking about skip distance. See, in the case of skip distance, I need to talk about minimum range. Minimum range I have to talk. So skip distance is given by 2h. H refers to height and FU/MUF divided by FC the whole square minus 1. And one more small concept is there. What do you mean by signal fading? Fading means like your signal is about to die. So you are having selective fading, interference fading as well as absorption fading. And apart from that, you are having that polarization fading and skip fading. So all these things are there. You just go through once. If you can able to remember, you just remember, or else what and all the things I have told just right now, it is more than enough. Now if you want a quick revision kind of thing, so till now what and all the things we have discussed? Till now what and all the things we have discussed is, we have discussed with respect to antenna types, and we have discussed with respect to basic definition, and we have talked about Frizz formula and broadside array as well as end fire, radio wave propagation and ionospheric propagation, also virtual height and skip distance. Now we have talked about antenna types. We are having dipole antenna, monopole antenna, loop antenna, helical antenna, horn antenna, paraboloid antenna. How we are going to classify means based on radiation pattern you are going to classify and then you are going to write. Now in the case of parameters, again I told you need to be very much concerned with respect to beam width, band width, radiation resistance, intensity, what is the efficiency, all those things you have to remember. Again you are having two ways of communication. The first one is you will be having a physical path, means predefined path will be there. Fading I am going to repeat again, just let me finish with this one, okay. See, in the case of communication, you are having two variants of communication. The first one is like you are having a predefined path. That means a medium is fixed, nothing but physical medium is known. But next one is wireless, nothing but there is no physical medium. You have to drive, you have to go on your own, right? So in the case of wireless communication, what you are going to do is you are going to make use of antennas. Nothing but you will be having one transmitting antenna and one receiving antenna. This is one mode of communication. In the second mode of communication, you will be having only one transmitting antenna, multiple receivers will be there. If I am talking about mobile communication, only one antenna, transmitting antenna, one receiving antenna. But if I am talking about this FM as well as AM, no, it is like one transmitting antenna, multiple receivers will be there. And even if I am talking about TV also, it's the same scenario. You will be having only one transmitting antenna, that is a base station, and rest of the things we are receiving, right? We can able to watch the signal. That is like you will be having multiple receivers, right? And the medium can be air, water, anything, right? And if I am talking about ionospheric propagation, you will be having several layers of atmosphere. Only one layer which is going to help you for communication means this is ionosphere, right? So ionosphere propagation is important. Now if I am talking about antennas, the basic antenna is isotropic antenna, where the signal is broadcasted in each and every direction. It is broadcasted, right? If you are broadcasting in each and every direction, what is the problem is practically it is highly impossible to realize. But even though if you are realizing what is the problem is, directivity will be very much less and range is also becoming less. So you are not going to make use. Only for understanding purpose we are going to make use of this isotropic antenna. Now what is the efficiency means, it is like if I am talking about helical antenna, it is what is the power in the case of helical antenna to power in the case of isotropic antenna. Or if I want to compare with respect to horn antenna, what is the power that is delivered in the case of horn antenna to the ratio of isotropic antenna. So reference is the isotropic antenna. So always for reference purpose you are going to make use of isotropic antenna. And even in the case of Fourier series and Fourier transforms, what you are going to do is you want to make use of the negative frequency. Practically negative frequency is not there. Only for like mathematical adjustments you are going to make use of that negative frequencies. Again, in the case of EMTL also I discussed, phase velocity, is it having any significance? No. For mathematical adjustments we are going to talk about phase velocity, and even I have told that phase velocity equals to infinite. Is this possible? No. Is this possible? No. But only for mathematical adjustments we can just talk about infinite frequency and like very high frequencies, all those things we can talk. Negative frequencies also we can talk. But zero frequency is possible. DC itself is zero, right? And if I am talking about radiation pattern, in which direction I am getting the maximum radiation? Nothing but I am trying to send in which direction? In which direction I am sending? So that direction is the main lobe. That direction is the main lobe. And whenever you are like walking along the path, you will be having the shadow also right with you. Shadow also is going to follow you. That shadow is something like back lobe. That shadow is something like back lobe to you, right? And you will be having that side lobe, which is again a waste kind of thing, but you can't reduce it. You try to minimize it, that's it. And what do you mean by beam width? What do you mean by first-null beam width? What do you mean by half power beam width, full power beam width? All those things you have to just go through it. Now, if I am talking about directivity, D equals to 4 pi divided by omega A, this formula you just remember. D equals to 4 pi divided by omega A, you just remember this formula, where omega A equals to theta HP and phi HP, right? With respect to horizontal plane, I am going to talk about the phase angles. With respect to y axis, if I am talking about y axis, and if I am talking about this x axis, this theta HP and phi HP is with respect to y axis and z axis, right? And directivity is given by 10 log of D if I want to express in terms of dB. How you can express means maximum power density to the ratio of power density of isotropic antenna or average power density of the isotropic antenna you are going to take. Bandwidth, how you are going to define means FR divided by Q. This formula you just remember, effective aperture equals to effective power divided by power density. Effective power divided by power density. You just remember these things. D equals to 4 pi AE divided by lambda square. What they want to test you is whether you know what is the relation between F and lambda. They want to test you. If you can able to remember this formula, what they are going to give is operating at some 300 kilohertz they can give. At that time you should be in a position to solve, right? Next, in the case of lambda by 2 antenna, radiation resistance equals to 73 ohms. You just flip to previous year question papers, how many times you can find this question. Radiation resistance equals to 73 ohms, match the following questions they will be asking. And Frizz formula is important. Received power equals to transmitted power into directivity gain of the transmitting antenna, directivity gain of the receiving antenna into lambda square whole divided by 16 pi square r square. Actually, directivity of the transmitting antenna should be like large, nothing but it should be a narrow one, and even in the case of receiver also it should be a narrow one, because only a band of frequencies we want to receive. And if I am talking about antenna, we are having isotropic antenna, we are having short dipole antenna, and we are having lambda by 2 antenna, lambda by 2 dipole.
Sir, that this formula is finding the radiation power.
Yes.
Okay.
Radiation power is nothing but like received power you want to talk, right? At the receiver, what is the power you are receiving? And at the transmitter, at what power you have just transmitted, right? Mainly the thing is you have to remember with respect to directivity. In the case of isotropic antenna, it is 1. It is very much less in the case of isotropic antenna. For rest all the antennas, it is greater than 1. You just remember this one. And if you can able to remember the values, it is well and good. And broadside array and end fire array, you just go through it. Phase difference equals to 1, phase difference equals to pi. And antenna array factor, I am telling you, this is important. E naught sine of n psi divided by 2 whole divided by sine of psi divided by 2. All those things I have given in the short notes I have given, right? So you just go through it. And basic difference between end fire and broadside you have to go through. This question they have asked in previous years. Match the following. I guess 49th question or 50th question. In 2017 or 2016 they have asked this question. L is very much less than lambda. How much less? Less than 50. That's it. L equals to lambda divided by 50. See, we know that in the case of magnetic field, this is the equation. Whether you can able to neglect this r square and r cube terms and like plus r power n terms is up to our understanding. In the case of near field, you can't neglect. In the case of far field, you can neglect. And what do you mean by elemental array? N elemental array they will be asking. Say suppose if one antenna if you are using, say suppose you can just you can just broadcast to some particular distance. Similarly, if I am making use of n elemental array, what is the thing I am going to do is I am going to increase the directivity as well as I am going to increase the power. All the radiations I am going to send it to a particular point only. So at this point, if I am talking about power will be more. So only they are going to make use of elemental array. 6 elemental array, 8 elemental array, 10 elemental array. Why they are going to increase means if you not increase the power, single antenna is not enough. So you are going to maintain a distance of d and then you are going to just transmit it. All these things are not important for UGC NET point of view. For gate it is important. And if I am talking about the lambda by 2 dipole, lambda dipole as well as 3 lambda by 2 dipole. See, in the case of lambda by 2 dipole, the radiation resistance is 73 ohms. Similarly, you try to calculate what is the radiation resistance in the case of lambda and 3 lambda by 2. And why you are going to make use is in one formula you will be having the beta L term. Beta equals to 2 pi by lambda, which is not applicable in each and every case. Again I am telling, beta equals to 2 pi by lambda is not applicable in each and every case. But in antennas you can take beta equals to 2 pi by lambda. And they can ask you like intrinsic impedance of air. Intrinsic impedance of air we will be getting 377. We will be getting 377. And in the case of antennas also, last block you will be having, right, that resistance is also equals to 377. Why we are going for this one means only for matching purpose, right? Similarly, we have to talk about V antenna. V antenna shape will be something like this. You just go through it. And radiation resistance is given by 80 pi square into L square divided by lambda square. You know, like they have asked this question a number of times. But if they are asking with respect to monopole, you just remember it is 40 pi square. See, this is in the case of dipole. This is in the case of monopole. This is in the case of monopole. You just remember this one, right? Next, if I am talking about radio wave propagation, the atmosphere is the one which is going to help for communication purpose. See, if I am talking about UV rays, which one is going to protect us, right? Which one is going to protect us means stratosphere is the one which is going to protect us. Which one is going to harm us? Troposphere, ozone is going to harm us. Similarly, if I am talking about communication point of view, we are going to make use of ionospheric propagation. And then you will be having E layer and F layer, all those things you just go through it, right? And main thing, yeah. And if I am talking about the frequency range, you just go through it. Very low frequency 3 to 3 kilo, only you just remember. And you remember this pattern. Very low frequency, then low, medium, high, then very high, ultra high frequencies, right? So replication will be very much easy. Where exactly you are going to make use of this line of sight, DTH? Why you are not getting line of sight? Because the buildings are more in number. And you can't place an antenna in some remote areas or like on top of the building you can't place an antenna. That is not a feasible solution. And if I am staying inside the house, line of sight I am going to break. So how you are going to overcome all those things is important. The best and optimum range is line of sight. Rest all the things is it is taking some time. See, in the case of clock skew, see if you are having this combinational logic circuits, in the case of combinational logic circuits also you will be having this clock. You are going to provide the clock, right? Say suppose if the clock edge is occurring at 10 microsecond, here also it should occur at 10 microseconds only, because synchronous. If it is occurring at 10.1 microsecond, then there will be a delay in clock, and this one is not preferred. Similarly, others also, like see, one wave has come in this direction. The next signal, the same information, if it is taking this pattern, that one how you are going to block is important. You are going to accept the data only once, rest all the things you have to delete it. And next you can get a wave which can be like this also, how you are going to remove this one, because it is taking more time, right? And how you are going to remove that one, all those things is not with respect to syllabus, only for your understanding purpose you can just relate with things. Next, if I am talking about ionospheric propagation, say suppose if I am increasing the height, say suppose if I am away from the ground surface or earth surface, a rate of ionization is going to increase, molecular density is going to decrease. If I am talking about skyway propagation, I will be getting multiple reflections. And thereby multiple users can be served. And even earth will be acting like a reflector. Yes, earth is acting like a reflector, but it is not a pure reflector kind of thing, right? It is not a pure reflector. Now if I am talking about Snell's law, I have to talk about two mediums with refractive index n1 and with refractive index n2 I want to take. So what does Snell's law tells means it is n1 times of sin theta I which is equals to n2 times of sin theta r. So this is what I mean by Snell's law. What do you mean by n1 and n2 means it is a refractive index of first medium and refractive index of second medium. Usually first medium you are going to take it as air only. And if you are talking about atmosphere, refractive index do change, because in the troposphere you will be having some refractive index, and in ionosphere the refractive index will not be the same, slight difference will be there, right? Now if I am talking about like air to water, if you want to propagate air to water, what is the refractive index? They will not be giving the refractive index of water 1.33, you have to remember. In the case of glass it is 1.5, tough glass what is the value, in the case of fiber what is the value, all these things are important, you have to remember. Similarly, if I am talking about critical frequency, Fc equals to 9 times of root of n max, and sine of theta I which is equals to under root of 1 minus of 81 n max whole divided by f square, right? And f maximum usable frequency equals to 9 into under root of n max whole divided by cos theta. So this relation also you try to remember, that's it, you just go through once, because like this topic if you are reading at last, no, rest all the topics you may forget. So which and all the topics you are very much good at, only you focus more on those topics only, because 65% is enough in order to get clear with the exam. Now if I am talking about virtual height, usually I will be getting a bent kind of curve only, but if I am extending that curves I will be getting a virtual height, nothing but this height is my virtual height, but actual height is only till here. So skip distance, how they are going to define is like first minimum distance they are going to call it as skip distance, and what is the formula? It is 2 times of h into under root of f maximum usable frequency whole divided by fc whole square minus 1, right? So this is all about skip distance. Now if I am talking about signal fading, what do you mean by signal fading? Means it is the fluctuation in the received signal strength at the receiver end. So I say suppose if I am sending 10 watts of power at the receiver, at the transmitter, at the receiver also I will not be getting this 10 watts, always there will be a degradation. The degradation, especially if I am talking about in a laboratory, if I am having equipments, I will be having all sorts of noise. I will be talking about what do you mean by short noise, what do you mean by thermal noise, what do you mean by environmental noise, all those things I am going to talk in a small area. But if I am talking about skyway propagation, at that time alone my signal will not be there. With my signal I will be having some lakhs of signal. So all those things are going to get interference, nothing but there will be a loss of data. How we are going to regenerate from that loss is what I mean by signal fading, right? What should be the like nominal range they are going to tell is it should be of the order of 10 to 20 dB you should have. Now if I am talking about the various types of signal fading in the case of radio wave propagation, in the case of radio wave propagation, you will be having some types of fading, right? So the first one is, they are going to talk it as selective fading. Selective fading. Similarly, the second classification is interference fading. Interference fading. And the third part is, or the third classification is absorption fading. Absorption fading. Absorption fading. And you will be having polarization fading. See, polarization you have studied in your EMTL also. I have told you a simple trick. With the help of knowing just equations, you can decide whether it is linear polarization, circular polarization or elliptical polarization. No need to equate that z equals to 0 and then E of 0 comma t and H of 0 comma t. No need to solve. By looking at the equation, by anyway you are having both hands with you. Just make use of both hands and you just think about whether it is left circular or right circular. That's it. You just focus on the things what I said and you just try to solve previous year question papers. Thank you for being on my channel. Please like the video, share this video with your friends and subscribe to my channel Craving Gyan. All the best for your competitive exams. Thank you.